Wayne, I've invented a thing.
Have you? That's really exciting. What have you made?
Well, I made a new crystal. It's all new and exciting and new and new.
A new crystal?
A new crystal. So, you know copper sulfate?
That's already a crystal.
But I crystallise it better. It's different because it has a different number of water to the other crystal I saw once. It looks like a crystal, that's the signature.
I'm afraid this is just copper sulfate pentahydride. They don't crystallise without water. They've all got water, I'm afraid.
Oh no.
I'm sorry to disappoint you.
Even 5?
Yeah, pentahydride, that's a thing.
Oh no. I'll have to try 6 next time.
It might exist, I don't know.
Oh no.
Would you make a car out of it? That'd be good.
That's what I wanted. I want to make a new car. But you can't blow up water.
You can't.
No.
So, question though, if you're an expert in this crystal field now, we've got this one, if I give you another one.
Alright, okay.
Na2SO4.10H2O. Name it for me.
Well, that would be sodium sulfate, is that it? And 10 decahydrate.
That's correct.
Alright.
So that's how you name the crystals. But unfortunately in your exam, you're not going to be asked just to name them. You might be, so it's a thing you need to know.
But you'd probably be asked to... They'll have an experiment they've made and they've given you results. Because often you don't want the water bit.
No.
So you burn it off in a crucible. You might have done the experiment where you put crystals in, then you make them go white, and then you weigh them and check the difference and stuff like that.
The sorts of questions you'll get, well, they'll all already have done that experiment, and they'll give you some data on it. So if I give you some data,
alright, you can see what you can do with it. Ahead of time.
Alright, so we have the hydrated salt MgSO4, or
Okay.
magnesium sulfate, .XH2O. That's the sort of question they ask. You'd want to find out what is X.
Yes, so I know to find out.
And they told you that that weighs 4.312 grams. They did the experiment that you just spoke about. They heated it up and they tell you the mass of the anhydrous salt, so just magnesium sulfate, is 2.107 grams.
Okay.
So it's going to ask you to calculate the moles of anhydrous MgSO4. So the first step's nice and easy. You have your mole equation, mass over molar mass. It comes up a lot.
You do?
You have the mass of magnesium sulfate. You know the MR is going to be 24.3 plus 32.1 for sulfur plus 16 times 4, which is 64.
And that is 0.0175.
So moles is 0.0175.
When you divide that by that.
Okay, so the second part of the question is now coming on to this waters of crystallisation chapter.
Okay.
It says determine the formula of the hydrated salt X. So that's going to be the step. Now the first step to do though is going to be doing a similar thing again but with water, but we don't know the mass of water. But do we?
We do. We know the mass afterwards. We know the mass before. The only difference is there's no water in this one. So the difference between the masses must be the mass of the water.
Yes, so that would be the first step, is to find out the mass of the water. 4.312 minus 2.107.
That would equal 2.205.
I believe so, 205. That would be the mass of the water. Now you can do moles equals mass over MR for water.
You can. So it's just 2.205 and the MR of water is 18. Get used to that.
16 is O plus 2 lots of 1 is just 2, so it becomes 18.
Yeah.
And then the reason we're doing this is if you have a moles of this magnesium sulfate and you have moles of water, you can use a previous chapter's stoichiometry, the molar relationships. So you can find the ratio between this and this, which is what stoichiometry means. And if this is an invisible 1, you can therefore work out what the invisible number here is.
Yeah, so what you do is you divide both of them by the smallest number of moles you've found, which happens to be this one, so you divide that by itself, it's 1.
And it will always be this one, because this number here is always 1, this number is a number. So.
That'll always be 1, but then when you divide water mole value by the same thing,
Stoichiometry is finding the relationship.
And that gives us 7 in this case.
So, if the
Then
relationship is 1 to 7, and this is 1,
the x must be 7, and that's how you do that sort of question. Yeah.
and
This comes up quite a lot often, it's quite mark heavy actually.
it is, yes. An alternative question they could ask on waters of crystallization is describe the experiment. It doesn't come up very often, this one's much more common.
Yeah.
But you maybe actually got to put it in a crucible, put the lid on, heat up the crucible to evaporate the water from the crystals. You'll be left with just this. You measure the mass before and after, then apply this.
Yeah.
And that's it really.
That pretty much is it. So I'll have to go back to the drawing board of my new crystal then.
Can I join you at the drawing board? I've become really good at drawing trees.
I love trees.